Okay, this video is the third in a series on non-parametric tests. We've done an introduction video. We've had a look at the distinction between the two, and we've also looked in a particular context of bivariate data between two different tests, one being non-parametric, that's the Spearman's rank, and the other parametric, which is the Pearson's product moment correlation coefficient. So this is the third one about something called the sign test, single sample. We will look at paired samples later on in the series. It's a bit of a blunt instrument, this. It is all about testing for a median. So it's test on median. And I suppose the fact that we're using the word the median is what we're testing on kind of implies non-parametric anyway, because median is all about ranking. A lot of data is lost when we're looking at the median. So non-parametric test it has to be. The process basically looks like this. First of all, we need to find number above in sample, above or below. It's arbitrary because we're talking about symmetrical distribution, or below below the median. Okay. Then use binomial NP, where n is the sample size and p is the presumed probability, p equals 0.5 of null hypothesis. Because if we're presuming the median is a particular value, then there's going to be an equal probability of a value being above or below a particular value. Okay, so and then what we do is we find probability of value being given value, this value, the number that's above the mean, or something more extreme. Or in the case of two-tailed tests, as extreme. It probably doesn't mean that much until I do an example, to be honest, but we can reflect back on it in a moment. And then, of course, what we need to do is test. Then we need to conclude in light of significance level. Okay, so here's an example. We've got 8 apples and we want to test to see if the median of the apples is 150 grams or whether it's different from 150, because there's no hint here as to whether we think it's more or less than. So we're null hypothesis here is that the median equals 150, and our alternative hypothesis is that median is not equal to 150. The null hypothesis in most cases, in pretty well all cases, is involving an inequality. And that's something that's always worth bearing in mind. So that is the null hypothesis, that the median mass of the apples is 150. The alternative is that it's different to 150, because actually looking at the sample we've got only one value which is more than 150. So let's work with that. So we've got let x be binomial with the sample size is 1, 2, 3, 4, 5, 6, 7, 8, with presumed probability 0.5 under the null hypothesis. The number of values above the median. And in our case here, the value of x is equal to 1 in this case. Okay, so what we want to do is find the probability of getting that value or something more or as extreme. I mentioned in two-tailed tests we have to be a little bit careful. So here, we've got 9 possible values for our binomial. I'm going to draw the graph. You wouldn't necessarily have to do this obviously to demonstrate, to actually do the test, but I'm just doing it to demonstrate my point. We've got 9 possible values that we can get. We can get a 0 to 1, 2, 3, 4, 5, 6, 7, or 8. Those are we can get those, and it obviously, because p equals 0.5, our kind of test statistic here is symmetrical. We've got the value 1. We've got the value 1 here. That's our actual value. So we've got to find the probability of getting that or something more extreme than that, something a little bit less likely, that one. However, because it's two-tailed test, we've got to also find the extreme values on that way, which is why I use the word as extreme, because obviously the 7 and the 1 are equally as extreme. Okay, so what we do is find a probability of that occurring by chance, in other words, presuming that p equals 0.5, and then compare that with our significance level. Basically, we're finding a probability of all of these 4 all added together. But it's probably quicker to use inequalities, use the thing on your calculator, not use the formula. So we're finding probability of all of those 4 added together, and yeah, so let's do that. So we're finding probability of all of those 4 added together under the presumption that p is equal to 0.5. I tend to write out like this: probability that x is less than or equal to 1, presuming p is equal to 0.5, plus the probability that x is greater than or equal to 7, presuming that p equals 0.5, which is the same as adding those 4 values together. But I say it's probably quicker, it's definitely quicker not to use a formula, because we've got a function on our calculator that can do that. And it's also going to be useful to use symmetry here, because we've got p equals 0.5. These 2 are going to be equal to these 2. So we can say that that's 2 times p x is less than or equal to 1, with p equal to 0.5. Okay, so that comes to, let's find a value, and we need to use the calculator here. So remember, it's the distribution function we want, and we want the binomial cumulative function, and we don't want a list here. we want to find a probability that x is less than or equal to 1 if the sample size is 8 and we got 0.5. And that's 0.3512, or that number there. That's 2, so that's 2 times 0.0, just to avoid rounding errors, I'm going to put 4 significant figures on that, which is equal to 0.0703, which is greater than the 5% significance level we're testing at. It's greater than that. That means it's not significant really. So we do not reject H naught. Interestingly, a one-tailed test would have gone below, but it was two-tailed. Had we suspected for some reason it was less than in advance of this, then we perhaps could have come to the other conclusion. But anyway, do not reject H naught. There is insufficient evidence to suggest the apples do not weigh or do not have mass 150 grams. It's not unlike this. The results we got aren't as, they're not unusual enough for us to reject the null hypothesis. Okay, going to do another example before finishing this video. Right, okay, here it is. I will put this one in. It's a one-tailed test, which we'll talk about in a second. It's a bit odd, that's why I put it in that, and this could happen. It's nothing in particular to do with non-parametric tests or the sign test in particular. This could happen with lots of hypothesis tests. It's a bit confusing how to set up the null hypothesis. You might be tempted to say, well, H naught, because the manufacturer's claim is that the median is at least, so median is greater than or equal to 6 hours. Okay, I'm saying this is wrong, by the way. I'm just saying you might be tempted to write this, but it would be wrong really. And therefore the alternative hypothesis is that the median would be less than 6 hours, because that's kind of what it says. However, we should never ever have an inequality for our null hypothesis, because we've got nothing to test against if we have an inequality. I mean, what do we call a median? Do we call it 6 hours, 6.5 hours, whatever? So we take it to the equality part of that. We have effectively then still, if we do end up accepting H naught, we have then, you know, gone with the manufacturer's claim, and if we reject H1 and we reject we reject H naught, if we reject H naught under the median is equal to 6 hours, we would definitely be rejecting H naught if we kind of let the median to be in something greater than 6 hours, because our probabilities will be even less. So by proving this, basically, or not proving, that's not a word we should use in hypothesis testing, but by suggesting this, by somehow coming to some kind of conclusion or inference from with our null hypothesis of equal to 6 hours, if we end up rejecting H naught, we would definitely be rejecting H naught if the median was somehow more than 6 hours. So, you know, we've kind of covered ourselves there anyway. So always equality for the null hypothesis, even if it's a bit confusing to set it up. Okay, so right now, once we've done that, it's all pretty straightforward here, I think. Here we've got 6 hours, of course, is 360 minutes. 360 minutes. and here we've only got one value, so we let x be number below, above median. You could make it below, it would be easier to do it above in this case anyway. Above median, it would be the same answer if you made it below. Above median. And so where x is, and we've got a sample size of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So x is equal to 10. Binomial 10, and I presumed under the null hypothesis p equals to 0.5. So and in this case we've got a value of 1. And we're at the bottom end of the tail here only, so we just need to find a probability of getting, we're not interested in these higher values, so we're interested in the probability of getting 1, or something even more unlikely, 0. Okay, unlikely, presuming p is 0.5, that is, or presuming the median is 360, or 6 hours. So all we have to do is find the probability that x is less than or equal to 1, given that p equals 0.5, because it's a one-tailed test. Okay, and then we can go to our calculator to work that, or we could use the formula in this case because we're only going to add two results together. But let's go to the calculator to do it. Okay, so we've got 7, and we need binomial, and we've got the value is 1, and the sample size is 10. That's 0.107. That's 0.107. Okay, and that is less than our required significance level 5%. So that does suggest that there might be something going on, that might be that the manufacturer's claim might be incorrect, because there's only one that's actually above 6 hours. So we say, and we write a contextual statement, but the first thing we say is reject H0. There is sufficient evidence to suggest the manufacturer's claim is false. That's probably enough, but I think that you might as well put it in the context that you might as well put a bit more context in there, that the median lifetime of candles is at least 6 hours. We wouldn't have tested any different, just to go back to this business again, we wouldn't have done anything different if the manufacturer had claimed that it was equal to 6 hours, but they claimed something a little bit bolder than that, that it's at least 6 hours. In any case, we seem to have found a little bit of evidence here at the 5% level. We found some evidence to suggest that that's false. Okay, so that's it for the sign test. It's a bit of a blunt instrument because we're really not taking account of how far any of these are from the median, and we can use the Wilcoxon's signed rank test to actually try and get a slightly more sophisticated test, which will come up in the next video. Okay, thanks, bye.